Okay, welcome to week 5, part 1. We're going to take a look at web scraping and web APIs in this lecture. This is a continuation of our theme of important but really awful things to know when you're doing Python programming. I'm going to skip over these couple of quiz pages. Okay, so our desire here is to get information from some website. And very broadly speaking, there are 3 different approaches to this. It may be that you can go to the website and simply download a CSV file or an ordinary text file or maybe a JSON file or something of that kind that you can then feed into a Python program to parse. It may be that the website provides an application programming interface, an API that you can call that will enable you to suck down data from within your Python program directly. Or last and worst, but not least, you can do what's called scraping the website, which is to say, grabbing all of the textual content of the website source code in HTML, for example, and parse the HTML to pick out the pieces that you want. Now, we have dealt with CSV files. CSV files are really easy to deal with, but you have to be concerned that the CSV file that you have may not be the most recent. And so you need to, if you're able to go with the downloading a CSV file route, you need to check periodically or check essentially every time you're going to process data to see whether there's a more recent one that you need to get your hands on. Okay, so web scraping involves sucking useful text out of an ordinary web page. Web pages are typically some kind of mixture of HTML source code, possibly cascading style sheet information, and also, in more advanced cases, JavaScript functionality. What we're going to look at in this material is basically just dealing with HTML and some CSS stuff using a tool called Beautiful Soup. If you find yourself needing to get information from a so-called active website that has interactive components, buttons that you need to click on and things of that nature, Beautiful Soup will probably not do what you need. And in that case, I'm going to just type the names of these things over here. If Beautiful Soup doesn't work, try Selenium or Scrapey, or perhaps something even newer and fancier than those that give you even more functionality. All right, so web scraping is horrifying. It's perhaps even worse than the kind of data cleaning that we did last week. The first step is you have to examine the actual source code, the source document within a web page, to have some idea what kind of things to search for using a tool such as Beautiful Soup or Selenium or whatever. If you happen to be using Google Chrome, your life can be made easier by using the web page DevTools capability built into Chrome, and we're going to talk about that. So, this is kind of awful. But once you have managed to wade through getting your scraping stuff to work, you're all set for a while. But if the producer of the web page changes the structure of the web page, then it's likely that your carefully developed web scraping Python code is going to fail miserably, and you'll have to kind of start all over again. In fact, this happened for me quite recently. I've been using information scraped from the U.S. Treasury Department describing historical yield curves, and abruptly, without warning, a few weeks ago, they completely changed the structure of their website. They changed how that information is provided, and so all of my carefully concocted, beautiful soup stuff now no longer works. All right, so HTML is an acronym for Hypertext Markup Language, and you've probably seen some, either intentionally or by accident, when you've looked at a web page. Basically, what HTML consists of is a hierarchy of beginning and ending tags. The notation... Okay, so technically that first character is called the left angle bracket, but I'm just going to call it the less than sign. So if you say less than, and then B, and then greater than, that creates a tag, and that is a starting tag. All of the information following that up to the corresponding matching ending tag, which is just less than and then a slash B and greater than sign, is considered to be a single HTML element. Okay? Sometimes elements will have attributes. So here we have a beginning tag, and there's the greater than sign at the end of the tag. This tag also has an attribute associated with it, which consists of a variable name, if you will, or an attribute name, and then an equal sign and some text. Okay? Elements are nested in a hierarchical structure. So here, for example, we have the beginning of the body of a document, and down here we have the conclusion of the body of the document. And within the body we have other nested tags. And many of these have a specific meaning when you feed these things into a web browser. For example, H1 means a big font header. H2 down here is a smaller font header. P is a paragraph of regular text. And I can also, if I want, specify style information using the div element type. Another way of specifying style information is to use the style element, and in here I'm specifying cities as a style, indicating background color, foreground color, a margin in terms of pixels, a padding in terms of pixels, and then I can refer back to that particular style in another div tag pair by using class gets and then whatever that predefined style was. And if you feed this information into a web browser, you'll get Pittsburgh displayed, white text on a black background, etc. Okay, now one of the most useful kinds of information to discover in a web page is a table. And in HTML, table is a specific kind of tag, and a table is assumed to have rows and columns more or less. All right, so within a table, you're going to find rows beginning with tr and ending with /tr, tr for table row. And then within each row, you'll typically have either table header information, which is just text labels. So here in this table, we have 3 columns: first name, last name, and age. Then, following the row containing the table headers, you'll have a whole bunch of table data actual column values. Okay, so this is a 2-line tall table that just has first name, last name, and age as the column names, with Jill Smith and 50 as the one and only data row. But obviously, this table could have hundreds or even thousands or tens of thousands of records in it, depending on how slow you want your browser to respond. Okay. Now, if you can discover in the HTML document a table, then there are very convenient ways of just sucking in the contents of a table directly into a data frame. If you're not able to find something labeled as a table, then you have more and more awful kind of work to do. So on the next slides, we're showing an example HTML description of a table, and we're showing how to suck in that table into a data frame. To do this, we've simply put the table HTML description into a file. Okay, so here is this is one continuous table split into these 2 rectangles. The table begins up here and ends down here. The first row describes the headers, and there's 4 columns: name, breed, weight, and age. And then we have 4 additional rows of data values. So Fido is a mutt who weighs 15 pounds and is 15 years old. Odie is an Irish setter who weighs 50 pounds and is 2 years old. Well, I guess it depends on the type, but a 50-pound Irish setter is probably an overweight dog. Okay, and then we've got Snoopy, who's a beagle, Barfy, who's a mutt. And let me show you this this file, and then we'll take a look at how to read the file in using the read HTML facility in Pandas. All right, so to kick this off, I'm going to say import pandas as PD. Just for paranoia, I'm also going to import numpy as NP. I don't think I'll need it, but it's nice to have in place. Let me show you the file, if I can find it. Okay, so I'm going to pull up a notepad and open the HTML file. Okay, so I've pulled up a notepad, and I'm going to open the table.html file. Click open on that. And Now let me drag this over where you can see it. Okay, so here is my table.html file. And it is very plain vanilla HTML table. Okay? Much more cleanly formatted than it would actually be if this were part of an actual web page. Now, I can read this thing in by using, from pandas, the read HTML function. So let me shift to my shell so that I can demonstrate that. All right, here's my shell, and I'm now going to say table gets pd dot read HTML of table.html. And poof, here is my table data frame. All right, so there we have it. We have a data frame that has 4 columns, 4 rows, and I can interact with the contents of that table. Now, by the way, at the top of slide 13 here, we're showing what a web browser would actually display if you opened this in a web browser. And in fact, I have done that. So here is a web browser that I created. Okay, I literally opened a Chrome browser and read in that table.html file into my browser, and I can see that in my browser I do have a nice looking table. The header row is in bold, and the data rows are in regular font. Okay. All right, onward ho. So, how do you find tables or other useful information within a website? Well, this is going to depend on the browser that you're using. And for us, if we're using Chrome, which I am, we can use what are called the dev tools to look around within the page and take a deep breath and try to look for meaningful elements. So let me pull up this website, forecast.weather.gov, in a browser, and we'll take a look at how we can use dev tools to look at that thing. All right, so here we have the result of going to this website, weather.gov, and what it provides for us is a map that we can click on to get forecast information about a particular location. All right, so if I click on, I'm going to try to click on Allegheny County here. I'll see how close I can get. All right, not too bad. And I'm going to pull down here and try to click right on Pittsburgh. And here we are. And if I scroll down a little bit, I see information about the upcoming 7 days worth of weather information. Okay, here we have a detailed forecast for the next 7 days. I would like to be able to actually access this information here. Today, sunny, tonight, partly cloudy, Wednesday, increasing clouds, high and low temperatures. I would like to be able to gain access to this information in my Python program. So I'm going to right-click somewhere on the page with my mouse, right-click, and notice I have an inspect choice down here. And now I have the HTML documentation or the HTML code that displays this particular website. And I can see both the website and the code side by side. Now, as I cruise down through the HTML code, you'll notice that in the left-hand side, the part of the web page that is controlled by or managed by that HTML code is highlighted. So if I'm right up at the top of the document, then the entire web page is managed by the top of the document. If I come down to header, then it's only the header part that is controlled by that. Body is the entire thing again. Here we go. Now header is just the header within the web page. All right, so it says National Weather Service. Navigation bar would display a menu for me that I can look at. Content area is all of the detailed information, blah, blah, blah. Notice down here, 7-day forecast. So I can come down to 7-day forecast. 7-day forecast is the detailed information that I'm interested in. The characteristics and the high and low temperatures for each of the next 7 days. And if I continue scrolling down, okay, I can click on these right arrows. The right arrows collapse an entire chunk of information into a single line. If I click on that right arrow, it will expand. And here we have the panel body with the 7-day forecast container. And if I click on that, 7-day forecast list. And here, finally, I get down to these things called tombstones, all right? And each day is described by a particular tombstone. Now, this terminology, tombstone, by the way, comes from the idea that, for example, on Wall Street, if you are announcing shares available for some company, that's usually done by putting this thing called a tombstone in the newspaper that announces the broker and the company and characteristics of the stock, et cetera, and it's a very formalized rectangle of information that is, that looks sort of like a tombstone. So here we have tombstones for the individual forecasts. So it's the tombstone stuff that we want. How do we get it? Well, we're going to look at a module or library called Beautiful Soup that's going to enable us to scrape this ordinary HTML website. As I mentioned, if you have dynamic web pages that have a whole bunch of JavaScript going on, Beautiful Soup is not powerful enough to help you with those. You'll need to use something called Selenium or something called Scrapey, or perhaps you can find something even more fancy and up-to-date. We're going to first use a facility called Requests, a library called Requests, to get the actual content of the web page. So we'll first import the requests library and then say requests.get to suck down the entire page. And after we've done that, we can then create a beautiful soup object from that. So let me walk through this example here a little bit. Pull up my shell again. Okay. All right. So I am going to import requests and import BS4. Assuming that you have installed Anaconda, these will be part of what is made available from having installed Anaconda. Now I can say page gets requests.get and type in my web page. And here we have just some, made up website. I want to go ahead and use my forecasts data from this government website. Okay. Now, of course, accessing a website might fail, and here we're doing something called raise for status to check for failure. But in this case, we're confident that website is there, or at least we're confident right now that it's there. It may disappear or be renamed or whatever in the future. And if I ask for the page text, it's enormously long. And I get told that this is 2,257 lines. Some of these lines are extremely long. I am not going to make the mistake of unsqueezing this text so that we can look at it. I did that before and hung my shell. But let's take a look at just the first. Let's take a look at the first 200 characters. And we see here that, okay, this is an HTML document, and here we have the head tag for the document. So this does appear to be, a legitimate HTML document from this very casual inspection. Now I want to create a beautiful soup object, which is a neatly structured form of the HTML. B-E-A-U-T-I-F-U-L, soup from the page's text. And now Beautiful Soup provides me a whole bunch of functions that I can call to pick out various portions of this HTML document. For example, I can use the select function. Select will scan through the Beautiful Soup document and give me back a list of anything with a certain tag. All right, so if I say x gets data.select div, okay, div for division, and I get back a list of 130 divisions. I can ask for x sub 0 to just see the initial division, and there we have the initial division description. To select a particular ID attribute, I didn't show you any of these, but there are many of the tags in the HTML have ID attributes assigned to them. Here I'm saying y gets data.select date, and y has nothing in it. Okay, so in this particular document, I got nothing to do with dates. I can also select nested hierarchies by asking for divisions within spans, or by asking for spans within divisions. I can also ask for the tables. I can ask for any tables that exist within the documentation, within the hierarchy, and so on. Okay, so we're going to take a look at finding some stuff in our weather forecasting site. And let me pull my DevTools back up here. Okay, so we've already found the 7-day forecast. We've found panel heading, panel title, panel body. And within there, we have the 7-day forecast container, the 7-day forecast list, and within there, we have the a sequence of these forecast tombstones. If I display more details about the first one, I get more detailed information. Okay, so today is the period name, and sunny is the description. High temperature 37 degrees is the temperature. Okay. So how can I get that stuff? Well, let me create a beautiful soup object from that web page. Here, actually, I already have this code in a source code file called mysoup. So let me pull up the mysoup. Okay. Okay, and I'm going to need to... Whoops. All right, so here is my soup. I need to shrink it down so that we can see it in my video. Okay, so we have imported requests. We have imported the beautiful soup data type from BS4. I could have imported all of BS4, but I really only need the beautiful soup type from that. And based on clicking on the map, I got back, and let me break this up into multiple strings. I got back this information with a more detailed URL with a latitude and longitude location for where I clicked. Okay, so that gets me an actual physical location, and I can then get from the website the information about that location. Then I'm going to parse that contents of that page using HTML parser logic into a beautiful soup object. And one of the facilities I can use on Beautiful Soup is find to search for a particular tag. Now, I did not prove that there's only one 7-day forecast in here, but you could search for 7-day forecast, and you would discover that there is only one. Within that 7-day forecast hierarchy, I can then also search for, and let me hit the enter key here so we can see everything, tombstone container. All right, I need to put that back together again. Whoops. Oh. All right. I'll get it back. There we go. Okay. We're going to search for tombstone container, and let me show you by taking a look at the stuff here that these tombstone containers are identified as class divisions. Now, here we have a little strange little peculiarity that I need to explain in the example, which is that in Python, class is a keyword. So you cannot, all right, here we said ID is 7-day forecast, and that works fine. But we cannot say class equals tombstone container, because Python will get all upset with us that we've used a keyword in the language. So we use this weird little trick of putting an underscore after class, and that will enable us to get the fact that we're looking for an HTML class. All right, so let me pull that back up. Where's my soup? There we go. Okay, so that's why we have this underscore here. If I eliminate the underscore, you can see I'm using idle, you can see that class is highlighted in orange, indicating that it's a keyword, and Python will not allow me to do that. So I use this silly underscore trick as well. Notice that I used find to locate just one 7-day forecast. But here I'm using find all, which will return to me a list of all of the tombstone containers. So let's run this thing, and we'll see what output we get. Okay, I'm going to press F5. I have to save it. And okay, so it pops up, and it's a little bit below where my recording is, so let me pull it up a little bit. Okay, so we went on to the next part here, which ends up displaying information about today. Okay, forecast items is a list. Let's take a look at that. So here's forecast items. Forecast items. And it's a list of 63 things. So we have a tombstone container for today. We have a tombstone container for Wednesday, for Thursday. Thursday during the day, Thursday at night, etc. So this is fairly lengthy. If I look at forecast items sub-0, then that just gives me the first tombstone container, which is about today. Prettify displays the HTML documentation in a clean format, and so that's forecast items sub-0 dot prettify will display the HTML hierarchy for that container. What did I do wrong? Dot prettify. Strange. It did not behave. All right. Well, I'm not gonna worry about that. So interestingly, maybe it's because I didn't say print. That doesn't seem very likely, but we'll try that. Print the prettified version. Oh, fascinating. Okay, so yeah, so it did matter that I sent. Okay, so what's actually happening here is that when I just said, all right, when I just said forecast items.prettify, what I got back was the internal representation of that information, which is just a very long string. Passing that same information to print invokes the stir conversion operation, and the stir conversion operation is what creates the nice-looking hierarchy of data. So I could have, instead of saying print, I could have just said stir of forecast items sub-0 dot prettify, and I would have gotten the all right, well, that's fascinating. Fascinating. Okay, I'm not sure what's going on there. In any case, so we used find to access the one and only 7-day forecast hierarchy, and then find all within that to find a list of all the Tombstone containers. All right, so the len of, I showed you this before, the len of forecast items is 9 long. So I have 9 tombstones. Now, within tonight, which they are using. Okay, so let me say today is forecast items sub-0. And if I now say today dot find class with my underscore to make Python happy is period name. Okay, period name, class's period name, and I want to get the text from that. So period name strange, I got no result. Oh, I misspelled it. That needs to be a dash. Yeah. Okay, so period dash name. There we go. And then if I say dot get text, that will just get the text part from within that that P tag, that paragraph tag. Okay, there we go. So that gives me today, and then I can do similarly for short description and temp, temp high. Okay. All right. Okay, so here is more mechanisms for interacting with this beautiful soup object. Here I am selecting all of the Tombstone containers period names. So let's give that a try. Period tags gets. Now I didn't create 7 day, so okay, 7 day forecast. Did I create 7 day? I probably did by executing the code. 7 day. Yes. So there's 7 day. And now I can select all the Tombstone containers. Seven day. Okay, and the examples here are using double quotes. Totally fine. I'm using single quotes. Doesn't matter. Let me just copy and paste that I want Tombstone container period name. And now there are 9 period tags, and I can print them. Or period names, I should say. And we have today, tonight, Wednesday, Wednesday night, Thursday, Thursday night, Friday, Friday night, and Saturday. All right. And now we're going to use get text. To create a list of these things. So pt.get text, and I'm using a comprehension for pt in period tags. Right? Whoops, I just realized I made a silly typing mistake. I forgot to call the get text function, which is going to actually get the text names of these periods. This will be much nicer. Okay, so there we go. If I want to get the temperatures in each of these 7-day tombstones, I can ask for the temperature attribute. All right, so that I don't make the same silly typing mistake, I'm going to be smarter this time and just copy and paste the thing. And print the temperatures. There we go. So now I have the temperatures associated with each of those dates. These are each lists. Notice, just for gags here, I have a list of the period names. I have a list of the temperatures associated with those period names. I could do something like period temps is a data frame created by zipping the periods and the temps with columns equal to period temp Oh, I restarted my shell at some point. So import pandas as PD. There we go. Okay, and so I can get, now that I've got the period names and the temperature information into a couple of lists, I can easily create a data frame out of those by zipping them together and providing, and giving column names that make sense. Okay, so it's pretty disgusting. And there's no, you just have to experiment and fight with it and Google for examples. There is official documentation. Let me show you where that official documentation is. I have it, I promise. Let me find it. Okay, so here is the official documentation at this kind of strange website, crummy.com, crummy.com/beautiful-soup/bs4/doc. And this has a lot of extensive information about examples of how to use Beautiful Soup. Google is your pal as well. You can just Google for Beautiful Soup examples and pick up a lot of things that way. If you need to use something like Selenium or Scrapey, there are plenty of examples, both code examples and also introductory videos describing how to do that. As we talked about data cleaning, this is kind of awful. It's kind of painful. On the other hand, it is extremely useful, and it is something that you should know how to do. Now, if you're lucky, you will have an API on the website that you want to access that you can just pull stuff down from. And the most common formats for information pulled down from an API here, JSON and XML are listed. CSV is also common when you pull stuff down through an API, and you can typically create data frames directly out of JSON and XML data. JSON data looks very much like a Python dictionary. It consists of a nested hierarchy of variable names associated with values. I'm not going to wade through the details here. And be warned that there is sort of a hierarchy of how things work with commercial websites. One of the advantages of government websites is that on government websites, things are usually free and also not usually very sophisticated in terms of their structure. But if you're dealing with commercial sites, they may charge actual money, or they may make scraping very difficult by having logic in them that tries to detect whether you're scraping. For example, if you're hitting commercial websites like Amazon or Best Buy or Walmart or whatever, they will try to detect how rapidly you're hitting their site, and if it looks like you're hitting their site too rapidly, they will cut you off and prevent you from accessing their site at all. There's a neat command called curl that you can use to download HTML from websites, and since we have installed Anaconda, even on Windows, it's available to us in our Anaconda shell. Let me just show a quick example. Here is the textbook that we recommend, the McKinney Python book, and this will download the JSON representation of the online description of that book. So let me pull up my Anaconda prompt. Here we go. And I'm going to copy and paste that web page if I can. Oh, I think it wants to take me to that web page. So we're going to have to do this manually. So I'm going to say curl and https://www.googleapis.com/books/v1/volumes Q is Python, and in the author we want to find McKinney. Bad illegal format or missing URL. Curl. Oh, I suspect it just doesn't like the quotes. I'm sorry. So let's do that again. And just get rid of the quotes. There we go. Required parameter Q. Required parameter Q. Required. What did I do? Volumes. Oh, I forgot to say Q. Q equals. There we go. There we go. There we go. And so now I have this JSON description of our textbook. And as you can see, it looks sort of vaguely like a Python dictionary. Okay. Many sites, even if they're free, do require you to get an API key. So when you go to a site and you discover that you need a key, you'll just have to request a key, and then you'll have to, provide that key when you try to access the website. Okay, I don't think I want to try to wade through these other things. You can just try them out yourselves. Here we go. Here's what I really wanted to show you. If you do download some JSON, or if you do download some XML, there are pandas read functions that will enable you to take the contents of a JSON file or an XML file and suck that directly into a pandas data frame. All right, well, that's enough awful fun with web scraping.